Hi, I'm Marlene Martinez-Sungard, the Surface Testbed Lead for the Mars InSight mission. We're in the In Situ Instrument Lab at the NASA Jet Propulsion Laboratory in Pasadena, California. This is a very unique lab. We have recreated some of the conditions on Mars like the sandy terrain. Here we are using crushed garnet. It simulates the Martian surface but has the benefit of being dust-free. Special lights are used to calibrate InSight's cameras to the brightness and color of Martian sunlight. That's me right there. InSight will be the first mission to study the deep interior of Mars. That includes using a seismometer to detect quakes on Mars, measuring the planet's internal temperature, and tracking the way the planet wobbles in its orbit around the Sun. This information will help scientists understand the planet's history, its interior structure, and how rocky planets formed and evolved in our solar system. So while it's going to Mars, InSight is more than a Mars mission. Today, we are testing the deployment of our instruments on the engineering model of the InSight lander. The actual lander will launch in the spring and land on Mars in November. Right now, we're using this model to test many different sequences that will eventually be used on the surface of Mars. Here's a time-lapse of one of our tests. Unlike what you see in the movies, our robots move really slowly. Deployment testing is a lengthy process that takes a lot of precision and patience. We use engineering models to practice maneuvers and troubleshoot problems before we try them on Mars. The actual InSight flight hardware was built by engineers at Lockheed Martin Space in Colorado. Over here, you can see the replica of the Mars exploration rover Opportunity that is in its 14th year of operation on Mars. Like the Opportunity rover model, we'll continue to use this engineering model after InSight lands on Mars in November. One of the instruments on InSight is a high-precision seismometer, which will help us analyze Mars quakes, which may be caused by meteorite strikes or by hot magma churning deep below. When a Mars quake occurs, the seismic waves provide clues to the structure of the planet's interior. Another instrument taking a flight to the Martian surface is a heat flow probe that will burrow up to 5 meters underground to measure the amount of heat escaping from the planet's interior. These measurements tell us how much heat is still flowing out of Mars, so we can understand how Mars evolved. When InSight launches from Earth, it will weigh 800 pounds at liftoff. Once it lands, it will only weigh about 300 pounds due to the lower gravity of Mars. InSight will then deploy 2 large solar panels that will power it over the course of its 2-year planned mission. When fully deployed, InSight is 19 feet 8 inches long and will generate about the same amount of power as a household blender. Time to get back to work. Thanks for stopping by.